Good day. Example number 3 of trigonometric substitution. Integral of dx over quantity of x squared minus a squared to the power of 3 over 2. So we let x is equal to a sec theta. X is equal to a sec theta. And then our derivative of our x is equal to a sec theta tan theta d theta. Then we have this dx a sec theta tan theta d theta over our denominator, which is 22x squared minus a squared to the power of 3 over 2. But before we can proceed, let us substitute the value of x in our denominator. So our denominator is quantity of x squared minus a squared to the power of 3 over 2. So we're going to substitute the value of our x. A squared sec squared theta minus a squared to the power of 3 over 2. And then let us distribute the exponent. A squared to the power of 3 over 2 times sec squared theta to the power of 3 over 2 minus a squared to the power of 3 over 2. And then let us apply exponent rule. So 2 multiply by 3 over 2. So a cube a sec cube theta minus a cube. And then take away the common a cube. Quantity of sec cube theta minus 1. And then try to see, we have these Pythagorean identities. So our final denominator after we substitute the value of x is equal to a cube tan cube theta. So this is our new denominator. Then let us proceed. Integral of a sec theta tan theta d theta over our new denominator, which is a cube tan cube theta. A cube tan cube theta. And then let us cancel out the like terms. We have this tan cube theta, and then we have this a, and then we have this a cube. So since our a is constant, so we take away the constant. So 1 over a squared. Integral of sec theta over tan squared theta d theta. Let us proceed. 1 over a squared. So here we're going to use the reciprocal identities and then the quotient identities. So the reciprocal identities of sec theta, that is equal to integral of 1 over cos theta over the quotient identities of tan theta is equal to sin theta over cos theta. But since we have this square here, we'll put square d theta. So as you can see, we have this 2 fraction. So we need to divide this one. So when dividing fraction, take the reciprocal of the second fraction, then multiply. 1 over a squared. 1 over a squared integral of 1 over cos theta, and then multiply by our second fraction. Multiply the reciprocal of the second fraction, that is cos squared theta over sin squared theta. Then, let us cancel out. So, 1 over a squared integral of cos theta over sine squared theta d. And then, in order to integrate this cos theta over sine squared theta, we will apply the u substitution. Our u, we let u is equal to sine theta. And then of course, our du is equal to cos theta d theta. And then, let us substitute. 1 over a squared integral of cos theta d theta, that is equal to du. So, du over, what is our u? Sine theta. So, u squared. So, our u here is sine theta. Then after that class, we're going to take the reciprocal of 1 over u squared, or take the inverse. 1 over a squared integral of the reciprocal of 1 over u squared is equal to u to the power of negative 2. Du. Then 1 over a squared integral of u to the power of negative 2 using power rule. We have this u negative 1 over negative 1 plus c. So, as we substitute, our answer is equal to 1 over a squared, or negative 1 over a squared sine, or inverse sine plus c, or 1 over negative 1 over a squared 1 over sine theta plus c. Then, the reciprocal identities of 1 over sine theta, 1 minus a squared is equal to, reciprocal of this 1 over sine theta is cosecant theta plus c. This is our answer, but not the final answer. Then, a while ago, we let x is equal to a sec theta. And then, we have this sec theta is equal to x over a. Sec, so we will use siya. Siya is equal to hypotenuse over adjacent. So, our hypotenuse is equal to x and our adjacent is equal to a. So, with that, we can draw a triangle. Our hypotenuse is equal to x and our adjacent is a. So, automatically, our opposite is square root of x squared minus a squared. And then, since our final answer is equal to negative 1 over a squared cosecant theta plus c. That is our answer. So, we need to find what is the value of cosecant theta. Cosecant theta is equal to that is equal to hypotenuse over opposite. So, what is our hypotenuse? X. So, cosecant theta is equal to x. And then, what is our opposite? Here, square root of x squared minus a squared. So, this is the value of our cosecant theta. So, our final answer is equal to negative 1 over a squared. Cosecant theta is equal to x over square root of x squared minus a squared plus c. So, this is our final